always overloaded with cameras and other stuff that I need to record my archaeological site. And I was always worried how to concentrate on what I'm doing and how to concentrate on taking care about all this equipment.
30 years ago, when we first started supplying ROVs to monitor divers in deep sea operations in the North Sea and off South America, we're just using hand signals, and the vehicles were just a camera and some lighting. And so improving the dialogue, if you like, between the vehicle and the divers, such that the vehicle can help the diver more and make the diver's life easier and make him more efficient, which makes it safer because then he doesn't have to spend so long down there.
Many scientists are dreaming of such a tool.
Caddy, Cognitive Autonomous Diving Body, is an FP7 project scheduled to start in January 2014. During the 3 years of the project lifetime, our research will focus on setting up symbiotic links between a human diver and a set of companion autonomous robots. The core of the proposed envisioned concept consists of a diver, autonomous underwater robot, and an autonomous surface robot.
The Caddy project is really interesting because in the near future we can imagine to have more and more underwater robots and also more and more autonomous underwater robots. But nevertheless, there will always be situations where human divers and robots have to work together. So there are many applications where robots alone are not the perfect solution, where divers alone are not the perfect solution. So this combination of having robots and divers is very nice. And then obviously you want to also have robot-diver interaction.
In the project we are going to develop the underwater vehicle that will communicate with the diver, and we are also going to work on navigation aids for the underwater system using the surface platform. We are going to use our autonomous surface platform for diver tracking, and also we will develop a new underwater vehicle which will be used for communication with the diver.
Our main activities within the Caddy project are first the development of a small robotic underwater body to support the diver operation, the development of techniques to achieve the coordination between the underwater and surface vehicle, also with following the diver operation.
So, and we'll focus essentially on 3 lines. So what we call compliant diver buddy tasks, where the buddy acts as a slave, so it sort of follows what the human is telling it to do. As another task, it will perform as a buddy guide, and in this case it will be the task of the robot to sort of guide the human along a path, for example, by telling the human how to maneuver by displaying information on the goggles. And also the overarching thing will be cooperative distributed navigation localization, where we'll have to contribute with algorithms and software.
My group is working a lot on 3D perception and 3D mapping, and that's also something we're going to do in the Caddy project. So the idea is to also map the environment where the robot and the divers are going to be interacting, and also perceive the diver and his or her gestures in 3D.
One of our main roles is going to be to provide the communication infrastructure for the diver and the vehicle. So we have to provide reliable communication between the diver and the vehicle and the surface vessel, and also to provide tracking and navigation using similar technologies. Another role we have is leading the work on actually sensing the diver in order to achieve the gestural communication between the diver and the vehicle.
Our task is to assess the internal states of the diver and give alarm if these internal states go, for instance, into panic. What robots can't do now is they cannot perceive humans. And they cannot interpret the internal states of a human, what a human wants, what emotions it feels, and so on. And Caddy, or our work on Caddy, could be advance in this direction?
Actually, we were planning to use some physiological measurements of divers that can be matched into the Caddy system. And we probably can also see how much the behavior of the diver can interfere in different physiological measurements as well, not only sociological way. This interdisciplinary approach, it's to me very innovative, very outstanding, and I think, of course, something new can just come out.
A vehicle that would unite all these necessary tools would be something that I would really love to see.
I'm looking forward to see if this actually can be done and integrated.